Hello, in this video we are going to continue to name compounds. We're going to focus on ionic compounds. But these ionic compounds that we're going to focus on, they're different from the ionic compounds we have focused on the previous video. On the previous video, we talked about ionic compounds whereby we have a metal reacting with a non-metal. In this video, we're going to talk about ionic compound whereby we have a transition metal bonding with a non-metal. So the difference is that transition metals, they sometimes have different ions, unlike metals. So but now, what do I talk about when I talk about ions? When I talk about ions, I talk about charges that we see on elements. For example, all the elements in group number 1, they are going to have one positive charge. Let's say, for example, we have hydrogen. Hydrogen is going to have one positive charge, and then lithium will have one positive charge, and sodium will have one positive charge. Moving on like that for all the elements in group number 1. But the elements in group number 2, they are going to have a charge that is positive 2. So for group number 2, for example, we have beryllium. Beryllium is going to be 2 positive charges. And then also magnesium will have 2 positive charges. And then also, if we move on to all these elements in different groups, we're going to have, this is group 1, this is group 2, and then we're going to skip all the transition metals to say this is going to be group number 3. We have group 4, group 5, group 6, 7, and 8. So now, the charges that we give for the elements that are in the left side of the periodic table, we're going to start to say we have 0 here, and then we have -1, -2, and -3. Also, the carbon is going to be -4. So now, let's say, for example, we want to look at these elements that are in group number 7. So elements in group number 7, for example, we talk about fluorine. Fluorine is going to have a -1 charge. So we're just going to write a -1. And then also chlorine in group number 7 is going to have a negative charge. But if we move on to group number 6 here, remember we have -2 as we count back from the right. So the oxygen is going to have 2 negative charges. So this is going to be 2 negative. And then also we have sulfur on that group of 6. So this is going to be sulfur will have -2. So now, all these ions here, they are fixed for metals and non-metals. But now, when we talk about these transition metals, for example, we can talk about a metal such as an ion. So an ion can actually have a +2 charge, and also it can have a +3 charge. So when we actually name a compound that is consisting of an ion, you will see that if we're going to have an ion that is having +2 charges, we're going to name it ion 2 with Roman letters. But now if you talk about the ion that is having 3 positive charges, we're going to say this is ion 3. So this is the difference when you talk about the metals reacting with non-metals and transition metals reacting with non-metals. The difference is that for transition metals, they can have different types of ion, even though it is one element. So now, let us now try to label a compound that is consisting of a transition metal and a non-metal. Let's say, for example, we have ion with chlorine. So now, how do we see that if this ion is actually an ion 2 plus or an ion 3 plus? So we have to actually know that, okay, chlorine is in group number 7. So in group number 7, a chlorine is going to have a negative charge. So this means if a chlorine, it is having a negative charge. But now we have 3 chlorines. So that means we are going to have what? We are going to have a negative 3 charge, because we have 3 chlorines. And each chlorine, it is having what? It is having 1 negative charge. So this means this chlorine will need to bond with an ion that is having a positive 3, because for these elements to bond, the positive ions and the negative ions must balance so that we can have this bonding of an ion and chlorine. So now, for us to label this ionic compound, remember this is still the same as ionic compound because we have a metal and a non-metal, even though this metal is a transition metal. So to label this element, remember we start first by naming the metal. So in this case, the metal is an ion. But now, what type of an ion is this one? Is an ion that is having positive 3. So this means it's ion 3. And therefore, if we label the second part, which is a non-metal, we're just going to name it. But now, remember, the ending is just going to change to IDE. So this is chlorine, but now this is going to change to be chloride. So the name of this compound here, it is actually ion 3 chloride. So we can also have a different type of a compound, which is ion 2 oxygen 3. So now, how do we actually see if this ion here, is it an ion 2 or an ion 3? So this number here that is at the bottom, it does not say that the ion that we have is ion 2. No, what says the ion is ion 2 or ion 3 is these ions here. Okay, so now let us check if ever the ions of this ion is going to be a positive 2 or a positive 3. How do we do that? We're going to say, okay, oxygen is in group number 6. So if it's in group number 6, remember it is having these negative 2 charges. So now oxygen, it is having negative 2. But now remember, we have 3 oxygens. That means we must multiply that negative 2 by 3. So in this case, we're going to have oxygen that is having negative 6 charge. So now we're going to look at the ion that we have. Remember now we have 2 ions. But now if we have 2 ions, what is it that we have to multiply with so that we can get the positive 6? Remember we have 2 ions. That is going to be positive 2 and positive 3. So we need to multiply with the positive 3 ion so that we can be having what? We can have what? We can have a 6 here. So that means if we have an ion positive 6 and also oxygen negative 6, therefore this is going to bond together and form this ion 2 oxygen 3. But now remember, this ion 6 here, it consists of 2 ions. The one ion that we have is what? Is the one that is having positive 3. And then also the oxygens that we have oxygens that are having 3 oxygens, but with negative 2. So now, to label this type of a compound here, what is important is only for us to actually check now what ions do we have for that particular transition metal. So in this case, this is still ion 3 because the ions is positive 3. So we're going to label this to say this is ion 3. And then we have what? We have a non-metal as an oxygen. So remember, for non-metal, we don't care how many number do we have or how many oxygens do we have. We're just going to say this is going to be ion 3 oxide. Remember, you always change the last part to IED. So we can also have different types of transition metals. For example, we can have copper with oxygen. So now, how do we label this? So now, you need to know that copper can actually be a copper plus 1 and a copper plus 2 because it's a transition metal. So we are going to first check now which type of a copper is this one. Is it a copper 1 or a copper 2? So we're going to say, okay, we first check, okay, oxygen is in group number 6. So if oxygen is in group number 6 here, that means it has -2 ions. So we're going to say, okay, oxygen, it is having -2 ions. And then this is just only one oxygen. So we don't have to multiply that -2 with anything. So this will mean that the copper, it must have the +2 ions so that these things can bond together when the ions are balanced. So do you see now the type of a copper that we have is a copper 2 because it has +2 ions. So to label this, we're going to name the metal, which in this case is a transition metal. We're going to say we have a copper, but now we have these 2 positive ions. So it's going to be copper 2, and then we have oxygen, so it's copper 2 oxide. So that is how we label it. We can also have another type of compound that is having a copper. For example, we have copper 2 oxygen. So in this case, what is happening here? We're going to have what? We're going to have copper 2 and we have oxygen. So the first thing that we check, we're not going to say this is going to be copper 2 because it's just from the reaction, we're just having 2 coppers and oxygen. But this does not mean it is a copper 2 by the name. Remember, what determines this is the ions. So now we're going to start to check how many ions does this copper have. So we're going to say oxygen is in group number 6, so it is having -2. But remember now, this oxygen is just one oxygen, so it's going to be having -2. But now in this case, we have 2 coppers. So now if we have 2 coppers, we must have -2 balancing with what? With +2. So that means this copper, it will have a +1 because it's going to multiply with these 2 and then it's going to be +2. So in this case, we are having a +2 and a +2. But now the name of the copper that we have is going to be what? It's going to be copper 1 because it has 1 ion. So now to name this, we're going to say we have what? We have copper 1, and then we label the non-metal, which is oxygen, so it's going to be copper 1 oxide. So remember, the last part always change to IDE. So we also have 2 special transition metals that do not have this type of Roman letters. So for example, zinc is also a transition metal, but zinc only has 2 positive ions. It only has those. It does not have any type of positive ions. And then we also have silver. Silver also has 1 type of an ion, which is a +1 ion. So this means when we label a transition metal with a nonmetal or an ionic compound that consists of a zinc or a silver, we don't need to include the Roman letters. For example, if we have zinc that is bonding with chloride, so in this case, it is a must for it to bond with 2 chloride because remember, chlorine is in group number 7, so it has -1. So that means we need 2 of them to have -2 because zinc, it is always having a +2. So now to label this here, because zinc cannot change the ions, it's just going to be what? It's just going to be zinc, and then we label the last part, which is a non-metal, to say this is a chloride. It's a chlorine, but we're going to change it to be chloride. So this is going to be zinc chloride. Okay, so we're going to do the very same thing if we had an element that is having a silver. Okay, so this is all that I wanted to cover in this video. I hope everything makes sense, but this part of transition metals and non-metals, it actually needs you to practice so that you have a better idea. So the elements that I've used, they are common elements that they actually ask in grade 10. So I hope everything helps.